3D printing is very popular. We can build shapes using plastic, or we can build very robust parts using metal. But there is another very interesting material out there, glass. Glass has many unique qualities. It isolates electrical energy, it's non-conductive, we call that. It can carry light, so your fast internet connection depends on it. It is very resistant to even very aggressive chemicals, and last but not least, it's transparent. When you think of glass, you think of a super brittle material. And indeed, bending a wine glass is not a great idea, so don't try this at home. But when we make glass structure thin like hair, they will suddenly be surprisingly flexible. As 3D printing is great for small, complicated and precise structures, we thought, could we add glass as a printing material? As a difference to other 3D processes, we won't add the material bit by bit. We start with a solid piece of glass and treat it with a laser. The laser has high energy and the lens bundles the beam. It works a bit like the magnifying glasses we use to burn paper with. The beam is focused in one point, so only there the properties of the glass are changed. It is changed in such a way that when we expose the glass to an etching liquid, the areas that were treated by the laser are being removed. So the result of the laser could look like that. Of course, the structures would be a bit more sophisticated than this. Speaking of sophisticated, one area where our glass structures are highly demanded is the watch industry. Currently, they're very restricted by milling and drilling. Thanks to our glass printer, they now can construct much more complex parts. Parts will make the already famously precise Swiss chronographs even better. It's also used in medical applications, for example at the end of a catheter that brings liquids into our body. And thanks to femtoprint, they could realize tiny and complex structures inside the nozzle piece. This application shows a tiny pin inside a pipe. It's used to measure the flow of a liquid. So if a liquid runs through, it will bend slightly, and thanks to transparency, we can measure this movement. We also work for One Drop Diagnostics, winner of last year's the Vigier Award. With our printer, they can develop their physical microchips much faster. From design to production, it used to take them 5 weeks. Now they get their parts in only 1 week, allowing much faster development cycles. I guess the quote of a client sums up the benefits of glass printing quite nicely. He said, "We're taking out all the plans we considered not possible, and now it can be done."